Okay, so first off, a logarithm. Logarithm is just a simple way to ask a specific question. Okay, logarithm is a simple way to ask a specific question that's actually going to be on the next slide. This is the makeup of a logarithmic function. Log, which is very standard, log, of base b, which is in the red, of a, which represents the number, equals x. Again, another number. B, A, and X can all be substituted in for numbers. They could also be variables. Okay? But it's read as log base B of A equals X. Okay? But it's basically a way to ask the following question. What exponent is required to go from a base B to reach a value of A? That is what a logarithm basically is asking you. To what exponent do I need to raise a base B to reach a value of A? Now, like I said before we started, is that logarithms and exponential functions, they are inverses of each other, okay? Which means sometimes to solve an exponential equation, you'll need to use logs. To solve a logarithmic equation, you'll need to use exponents or exponential form, okay? And so this is how you can go from one form to the other. Exponential form, which is you have a base raised to some exponent equals an answer. That can be written as log of a base of an answer equals your exponent. I color-coded it for a reason, so that way you can see the base in your exponential form is the same as the base in your logarithmic form. The exponent in your exponential form is what the log equals in the logarithmic form. And the answer for the exponential form is the of part in your logarithmic form. Okay? And yes, being able to go from one form to the next is going to help you out when it comes to solving and when it comes to evaluating. Okay? Does everybody have this down? All right. Before we look at the inside of this foldable here, before we get to those examples, let's look at a couple of things, okay? That's what the yellow sheet is, okay? Let's look at the yellow sheet. First, a way to remember how to go from one form to the next, okay? It's called the logarithm loop trick, okay? Always draw a loop counterclockwise from your base, okay? So if you start here and counterclockwise, with your arm, I want you to show me what's counterclockwise, okay? Counterclockwise, you're making a C, okay? So if I draw an arrow going counterclockwise from the base, it basically tells me how to write either in exponential form or in logarithmic form. So you start with your base, you'll hit your answer, or sorry, your exponent, and then your answer. Same thing here, base, answer, exponent. That's how you go from one to the other, okay? So this is called the logarithm loop trick. You start with here, you're here, and then you're here. So how do you write this in exponential form? It's going to be 4 to the x power equals 64. That's how you go from one to the other. Did everybody see that, or did I do that too fast? Okay. So you always start from the base. So that's number 1. So that's 4. We loop to the x, and that's in your exponent, and then that's going to equal 64, where we end.
So you just end, when you end it to get to the third one, you just stop at the first, like the first number or exponent or base.
No, we started at the base, we ended at the 64. So we started at the 4, we ended at 64.
So whatever's in front of the base, and that's where you end?
Whatever's after the base, that's where you end. Yes. Okay? Same thing here. Do the loop. This is 1, this is 2, this is 3. This is how you go from exponential form to logarithmic form. Of course, you got to have your log because you're going to logarithmic form. The next thing comes a base. Then your 7. That's going to equal x. This is how you go from exponential form to logarithmic form. Okay, so a few things you need to know is that sometimes a logarithm can have no base. Okay, that's okay. Because anytime the base of a logarithm is not written, it is assumed to be the number 10. Okay? Anytime the base of a logarithm is not written, it is assumed to be a 10. So if you want to, you could write in a 10. These type of logarithms are what you called a common logarithm. Okay? Okay, these are called your common logarithms because these are the ones that are most commonly used. If you've ever seen your calculator and you've seen that log button, whether it's on your phone or that scientific one that we have over there, that log is only a log that has a base of 10. Okay? Which means that the only types of logarithm problems that you can do in your calculator are ones that have a base of 10. So if it has a base of 4, like that one on the other slide had, you wouldn't be able to just to be like, oh, I'm just going to use the log button on my calculator to get the answer. It won't work that way. Okay?
So it's like 10 is just like the standard.
10 is the standard. The common logarithm. Okay? So, all of these are examples of logs that have no basis. But they can be written as log base 10 of 10. This one here, log base 10 of 1 over 100. This one can be written as log base 10 of 1,000. Okay? These are some examples of common logarithms. Okay? So, being able to take a logarithm and write it in exponential form is a skill that you're definitely going to need for solving as well as evaluating. Okay? Being able to go from exponential form to logarithmic form, you do need that skill. It's not always used, but it's good to know both ways, that you can go both ways. To actually evaluate these without using your calculator, you're going to want to rewrite them in exponential form. Okay? You're going to want to rewrite them in exponential form. So that's what we're going to practice first. We're going to practice writing these logarithms in exponential form. And we're going to practice going the other way because we can't do one way without the other. And then we're actually going to evaluate them, all right? So go back to your white sheet. Open it up. Okay? And do I want to start with these or do I want to start with these? Yeah, let's practice converting, okay? So on your left side, you see these problems? They're on the right side. On the left side of that page, you have exponential examples. On the right side, you have logarithmic examples, okay? You're going to convert your exponentials to logs, your logs to exponentials, okay? And just like before, you're going to use the loop trick, okay? You start here, and you loop around. So you start with 1/5, you go to y, then you end with x. So to write this exponential equation as a logarithmic equation, you need your log, of course. Your base is going to be 1/5. And please make sure you guys distinguish your bases from like your regular numbers. It should be small and it should be in a subscript. Then the next thing is going to be y. Y is not a subscript. It's literally on the same line as your log, the same size as your log. And it's going to equal x. And we have rewritten it in logarithmic form. That's it. Okay? Let's loop again. We start at 9, loop around, end at y. So 1, 2, 3. This is going to be log base 9 of equals. Very good. Keep going down that side. Do those next, 4? Do those next 4 problems right in logarithmic form. So for the next one, this one here, when I make my loop, this is going to be log base what? Of equals. Make sure that your base is indeed a subscript. It should be below like the same line your log is on, okay? It shouldn't look like 6x. It should look like a base of 6 and then an x. Loop around again. Log base what? Of equals. Very good. Okay? Log base u of equals. Good stuff. And then the last one, log of base 8 of a equals b. You're good with writing it in logarithmic form? Awesome. Let's go exponential. It works the same way, okay? You loop around, starting at your base, which is the small number, and then ending at the of, okay? So this becomes u raised to the v power equals 15 over 6. Does everybody see how that works? The same thing, loop around. You start at your base and you end at your of. So that's going to be a base of 7/4 raised to the y power equals x. Now these, of course, these are not, like you can't really do much from that except to rewrite. But this skill right here is how you actually are going to evaluate logs without using your calculator. Okay? Do you guys understand?
Yes.
Can you do the next 4?
Yes.
Okay. Do the next 4. Okay, let's bring it back. Andrew, what'd you get for the first one?
U to the negative 16 equals B.
Very good. Elise, what'd you get for the next one? Very good. Neil Marie, what'd you get for the next one? Very good. And Elvin, what'd you get for the last one? Good stuff. Okay? That's a skill that you need to evaluate logarithms. Okay? So, when you're trying to evaluate, you want to write it in exponential form. As you can see, question?
You raise them to the negative.
Mm-hmm.
Do we not put them like under the
If we were to continue to evaluate, we would. But because we're just rewriting, we will leave it just as that. Oops. For these, none of them are equal to anything. You need to have it equal into something, okay? So just go ahead and put an X, okay? Anytime it's not equal to anything, just put an X. It's definitely going to make the loop make a little bit more sense because you need that one. So we loop again. And we rewrite in exponential form. This becomes 4 to the x power equals 64. Your job is to figure out what number do I need to raise my base to get 64. And if you know your powers, this is going to be easy. It's 3. Okay? You need to know your powers. I wrote them out on Thursday, a lot of them. Okay? So knowing those are going to definitely be helpful. Same thing. Let's loop around again. This is going to be 4 to the x power equals 16. 4 to what power gives you 16?
2.
You guys are evaluating logarithms right now. Good job. Loop around again. To evaluate a log, you want to write it in exponential form. So that's going to be 6 to the x power equals 216. It is 3. Trust me, you're going to do plenty of these that by the time you're done, you'll know at least all your powers, like 1 through 8 up to 3. Okay? But yes, 6 to the third power is 216. Now this last one, when I loop around, it is going to be a negative. This is 3 to the x power equals 1 over 243. The only way that 3 is going to change to a fraction is a negative exponent. Okay? And if you want to, remember we rewrote exponentials so that they have the same base. You could do the same thing here. 3 to the x equals, this becomes 3 to the negative fifth power. Set your exponents equal to each other. X equals 5, negative 5. Questions? Yes?
So if you plug in the -5 and then use the 1
Uh-huh. That's how we're able to get to the 1 over. All right? Questions? Do the next, 6? Do the next 6. No calculator. All right, Leah, rewrite the first one on the left side in exponential form for me, please. Equals 125. Let me add in all my x's here. And Jackson, what's the answer? Yeah. X equals 3. Very good. Going down. Michaela, write it in exponential form for me, please.
343
Very good. And Garner, what did you get for the answer? X equals 3. Nah, not 3. Not 3. Not 3. How could I rewrite 343 to the same base as 7? 7 to the third power. So then this changes to 3x equals 7. My bases are equal, so that's 3x equals 1. So x is going to be a 1/3, not a 3. Okay? In this particular case, my base is larger than what it has to equal, which means that it's going to have to be a fraction. Okay, when that happens. When the base is larger than what it's going to have to equal, it's going to have to be a fraction to get it down. Okay? All right. Abby, rewrite this one in exponential. Okay, and Alyssa, what's my answer for x? 1/3. And question, Amy. -3 would only cause this to flip and become 1 over this to the third power. That still won't give us 7. This gives us 1 over a really, really large number. Okay. All right, up here, Zoe, write this one in exponential form for me. And AJ, what's my answer for x? It's 2. Very good. Let's see. What have I not called on? Isabel, write this in exponential form. Very good. And Amy, what's my answer? 4. Okay. And who have I not called on? Have I called on Eric? Jonathan, write this in exponential form. And Taylor, what's my answer? 3. It's got to be a -3. Because if it was a +3, that would just give us 216, but I need to be 1 over 216, which means it has to be the negative. Did you say negative? I just didn't hear you. Okay. Questions on rewriting and evaluating logarithms? Okay. So having that skill, being able to write from one to the other and back, you'll see it again, especially when we get to solving these logarithmic equations, but that's not until tomorrow. We're going to shift gears, get this glued down into your notebook, and we're going to look at the properties now of logarithms. Okay, so we're moving on to properties of logarithms. Okay, there are 3 different properties. There are a few special rules that are involved with logarithms. Yes, gonna need to know them. Okay, so starting off with your multiplication rule. Okay, everything's pretty much laid out for you guys here in this foldable, so just make sure that you're following along. The multiplication rule is basically used if you need to either condense a logarithm or to expand a logarithm. Where you might use condensing a logarithm is if you're trying to solve a logarithmic equation. But you can also go this way as well, expanding, okay? So this right here, reason why it's called multiplication rule is because this is x times y. And so then to separate x from y, as you can see, it's log of the same base b of x plus log base b of y. Okay, so multiplication rule, you expand it by using addition, and also vice versa. You can condense it if there's an addition symbol just by multiplying the x and the y together. Here are 3 examples that are already worked out for you. You have log base 2 of 3 times a times c. You can expand that, since all of these are multiplication, by basically rewriting log base 2 of 3 plus log base 2 of a plus log base 2 of c. Do you see how the rule is used? Multiplication, you can expand it by putting in addition symbols. Here's another one. You have log base 3 of x squared minus 25. Now do realize that you just can't expand that without doing anything extra because, one, this is a minus, all right? And plus this is multiplication rule, so we need something to be multiplied together. But we can factor this to be x plus 5 times x minus 5. And at that point, we're able to expand it as log base 3 of x plus 5 plus log base 3 of x minus 5. Yes? Because when you expand this, you have to keep the log with the respective base for every piece as you expand it. So that log base 2 has to be at every single term. The only time it won't be there is, let's say, it's log base 2 of like another number that can simplify to be a number, then it'll go away. This also applies not just to logs, but also to natural logs. Natural logs, ln, is the inverse of one particular exponential function, which is e. Have you guys ever seen this before? Not even maybe passing on your calculator or anything like that? Okay. This is a specific type of an exponential function, which we'll talk about in future lessons, but ln is the inverse of this. So this rule here also applies to ln's as well, okay? So then the ln, let me rewrite that, that's ugly. The ln of xy would be written as the ln of x plus the ln of y. So then here, there, yeah. It would say if it's natural, it's going to be an ln. They're not going to use, so ln is a natural log, log is log. No, we're going to go over 3 rules. So this rule applies for the natural logs as well. So far, so good? Okay, so let's look at these examples. It says try these, okay? We have log base 3 of 2xy. What's connecting 2 to x and to y? Multiplication. So we can expand this by basically rewriting this as log base 3 of 2 plus very good. Okay? What about B? Say again. How so? Hold on now. So that can be factored. You could add in the 10. You don't have to. But a good way to recognize it. There's no base here. So it's assumed to be 10. Now, you do not have to write the 10 for common logs, but you do need to be able to recognize that it is a 10, okay? So we can expand this by saying log of 6x plus 1. Exactly. Everyone good on multiplication rule? This last one, A, B, and C, they are connected together with multiplication. So this will be the ln of, keep going, plus the ln of B, plus the ln of C. Simple as that, okay? Now, considering that this piece of paper is not going to take up too much space on your sheet, okay, we are going to do some extra practice, all right? So, do I want to do it now? No, I'm going to get the author rules first. I'm going to get the author rules first. Quotient rule is next. Quotient means division. So this time we're dividing x and y, and we can expand that by making it a minus. So multiplication is with addition. Quotient is with subtraction. Division is with subtraction, okay? So similar process now, except instead of there being a multiplication and addition, it's division and subtraction, okay? As you can see here, you're dividing x minus 8 by z. So you can expand that by saying log base 4 of x minus 8 minus log base 4 of z. The next one actually combines multiplication and quotient rule together. Does everybody see that? It is 5 times x divided by q. So you can expand the division and turn it into subtraction by saying log base 11 of 5x minus log base 11 of random 6. Don't know why that's there. Okay? Of q. But then you can split up that log base 11 of 5x because it's multiplication. So then it turns into log base 11 of 5 plus log base 11 of x minus log base 11 of q. Does everybody see that? It's multiplication and quotient together. All right. And then the last one, x divided by x minus 5. You can expand it by saying ln of x minus ln of x minus 5. Questions? Are these the next examples that you guys have? So remember, division means what? So this becomes log base 5 of x minus log base 5 of y minus 2. Make sure whenever you're expanding, that log with its respective base goes with every term as you continue to expand it out. Okay? This one you have to be careful. We can start with quotient by saying what? Of A. B, C. Now do realize that B and C are combined together by what? Multiplication. So we can expand the second part right here by saying what? Wait, hold on. Wait, log base 4 of B, log base 4 of C. Now do realize that you are subtracting that entire log. So what does that mean? Huh? Ooh, I'm glad I didn't have nobody grades up. Okay. Well, you start by doing addition because it's multiplication right here, B times C. But because it's a minus that entire log, you're going to have to take that negative and distribute it over. Does everybody see that? So then it becomes log base 4 of A minus log base 4 of B minus log base 4 of C. And that's your final answer for that one. C looks a little interesting. Yes? You talking about B? Why can't we leave out the first one? Because the first one had a y minus 2. The operation that was separating the y and the 2 was the subtraction. And there's not one to expand it using subtraction. It's only multiplication or quotient so far that you've learned. So since this is multiplication, you have to continue to expand it more. Otherwise, it's not completely. Okay. What do you think about C? What do you think I should do? Yes. I should probably bring the x down, right? So this becomes the ln of 5 over xy, and then I can ln of 5 minus ln of x, and this one's going to be ln of y, because remember, we're going to have to split that one up and then distribute over the negative. Questions on quotient? Yes. Because it was a negative 1. If I didn't, then we would have had to we would have used the multiplication rule for the 5x to the negative 1 for that, but it still would have ended up being that minus ln of x once I fully expanded it.
So if it wasn't a 1 and it was like a 5, would you just put minus ln x to the 5th power?
If it wasn't a 1, if it wasn't a 5, it was a 1.
Like if it was a 5, so would you have minus ln x to the 5th power?
Oh, you're talking about if it's something other than 1. We're actually going to talk about that now. Yes. Okay? Power rule. This is when your exponent is being raised to something other than 1. Okay? As you can see, you have a log base b of x to the r. That can be expanded by moving that exponent to the front of that logarithm. So that becomes r log base b of x. And as you can see in these 3 examples, whenever there's an exponent, you bring it to the front. Okay? Number 1 is the most simple, most basic. Now for number 2, this is the 7th root. Remember, radicals can be written as exponents. So the 7th root can be written as x to the 1/7 power, and then you apply the power rule by bringing the 1/7 to the front. Now because there's already a 6 there, you multiply 6 and 1/7 to get 6/7. Everybody see that? No? Okay. So first off, in order to apply the power rule, you have to rewrite that 7th root as to the 1/7. We know that rule, right? So then if this 6 wasn't even here, this would be 1/7 log of x by applying the power rule. But because there's already a 6 out there, we just can't ignore it. So you multiply it. Because basically r is being multiplied to the log base b of x up there. So you just multiply everything together. And that's how you get 6/7. Okay. And the last one, again, even with ln's, this applies. But when you multiply, if it does simplify, you want to simplify. Okay? Everyone good? Okay. So,
An example 3.
yes.
Why did ln x equals 4 just change to ln x?
An example 3? Okay, so remember this turns into, oh, because when you bring that 1/3 to the front and you multiply 12 by 1/3, 12 divided by 3. That's how it turns into 4.
But the 4 disappeared.
No, it didn't. It's right here.
Oh, that's not. Oh.
Okay. Are these the next examples for your power rule? No? Okay. So I mixed up the boards. My mistake. Okay, is these?
Yes.
Okay. So if I bring it, I apply my power rule here. So that 5 needs to go where? So this becomes 5 log base 7 of x. Simple as that. Before I can work with b, I'm going to have to change that, not to 1/5. This becomes 5 over 2. Since there was already an exponent in there, remember, The square root can be changed to x to the 1/2. So if there's already an exponent in there, you just multiply the two together. And then from there, I can bring the exponent to the front. 5/2 times 3, which is what? So this becomes 15/2 log base 4 of x. Now for the last one, it's incorporating two rules here. What rules here are we incorporating for this one? Power and multiplication. So before I apply any rule, I probably want to rewrite the cube root of x to what? X to the 1/3 and fifth root of y to 1/5. Now, am I going to apply my power rule first or my multiplication rule first? It's going to need to be multiplication because I'm going to need to expand to separate that x to the 1/3 from that y to the 1/5. So this is going to become 15 ln x to the 1/3 times 15 ln y to the 1/5. That 15 ln is going to go on both terms. Oops, and sorry, needs to be addition and not multiplication.
So then it's going to be 15 ln x y.
We're expanding. No, it's not done. I got to bring that power to the front. So so then 1/3 times 15 becomes 5 ln of x, and then 3 ln of y, and then that's my final answer. Questions? All right. Those are your rules. Those are some of your properties. Okay. Those are some of your main properties. Some of your other common special rules and properties are what you see here in the dotted box. When you have a log of a base b of the exact same number, that's automatically going to be 1. If you ever forget that, yes, you can rewrite it in exponential form and see that it's going to have to be 1. But to save you some time, if you have the same base and the of are the same, then it's going to equal 1. If you have a log base b of b to the m, so if your base and the of are the exact same, it's just going to be what your exponent is. Log base b of 1 is 0. Anytime you have a 1 over a number that ends up becoming a negative log, the ln of e is always 1. The ln of e to any exponent is just the exponent, and the ln of 1 is 0. Ms. Anderson, are we going to have to know these? Yes, you're going to need to know these. Okay?
So are you just like integrated through the test? You're gonna add this to like
No, they're going to be like integrated through. So like, for example, if you were to expand something and it ended up being that when you expanded it, say you had log base 4 of 4 plus log base 4 of x, say you had something like that, I'm expecting you to be able to recognize that log base 4 of 4 is equal to, not 4, 1. So then your answer would be 1 log base 4 of x. Do you see how that goes? So it's just a matter of simplifying. Okay? Yes. We haven't had any of those yet, but now that I've gone over them, you're going to have them now. Question? Yes. E is that exponential function that I was talking about. E is a set number. It's like 2.71728, da 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 da. It's like a non-ending number, and so it's a special base, and so that's what it is. This one right here, this last one at the bottom, log base b of x. This is a formula. It's called change of base formula. This allows you to find the log of any number using your calculator. Okay? It is not it's a simple process, but it's not as simple as just pressing the log button and then the number. okay? You actually have to separate, as you can see here, log of x divided by log of b, and then you'll be able to get your answer. This should look familiar because we did it back in Unit 2 when we were doing finding the exponent. And remember how back in like first quarter I said, don't worry, we're going to get to this? Well, we're now here. Okay? And there's some examples there worked out for you already. Okay? So let's do some on our own. What's going to be log base 4 of 4 to the 5th power? 5. Okay, that's that rule that says log base b of b to the m power is just m. What about the next one? Log base 7 of 7 is?
1.
Always. You ever forget, you could rewrite it in exponential form. ln of a 1 over x. Negative ln of x. Yes, even though that one had a log, where is it? Here? This one still applies to the ln's as well. So ln of 1 over x is negative ln of x. Come on, there you go. Oh crap, where am I? All right. What about this one? ln of e, a plus b. Just a plus b. Anytime you see ln of e, that automatically cancels out and you're just left with whatever the exponent is. In this case is a plus b. And now the last one. Interesting. Huh? Log 5 of 1/5. You can condense these together. Because it's addition, you can use the multiplication rule to rewrite it as log base 5 of 1 times 1/5, which is just 1/5. But I can keep going. What is log base 5 of 1/5?
1/5 log base 5.
Log 1/5 over log 5.
I could use the change of base formula here. That would give me an answer, but then I would need a calculator for that. And if I say no calculator, then what you gonna do?
Oh, wait, that's not an exponent, that's an answer. It's the a. It's negative log 5.
Okay.
Is it 0?
5. Base 5.
Yeah.
Base 5, 5.
Negative log base 5 of 5. And what's log base 5 of 5? So this becomes negative 1. Okay. That right there, I think let's see, we use the multiplication rule, okay, to simplify. We use that one special rule there to bring the negative out front, and then we use the other special rule. Log base 5 of 5 is 1. This gets easier as you continue to practice them. It does get easier as you continue to practice them, okay? Questions up there? Yes? Remember multiplication right here? Okay, it works both ways. If you have adding, you can rewrite it just multiplying the x and y together. So in this case, x and y were 1 and 1/5. Or you could also use the special rule to say that this is equal to 0. Yes?
What's the rule that when you
So one of the special rules, if so, it doesn't have a name.
the second one, the log 5 that one.
Oh, this was just multiplying those together. So there was no rule to connect this to this. Isabel? Do you hear me? Mia, my bad.
How did you get like 1/5 to the 5?
This one here?
Yeah.
The rule that says, off the top of my head, I don't remember the exact order. Where is it? There it is. Okay. 1 over b to the x can be written as negative log base b of x using that rule. So x in this case is 5 and b is 5. Yes. What rule? C was this one right here. Actually, this one. No, we'll see. So lots of things. And again, it gets easier as you continue to use them. They become like second nature. They do. They really do. Okay? Last little bit. Condensing and expanding. This is when you can take the most complicated of logarithmic expressions and expand them out all the way. You have 3 worked out examples of how you can expand a logarithm or condense a logarithm. But either way, they're using the rules, they're using the properties to do so. Okay? Let's take this one. You have the square root of x to the third y over z to the fourth. They rewrite x, the square root, as a 1/2. And then they apply not only quotient with the subtraction, but also power with that 1/2. Is everybody with me up to the second line? Okay? So if anything, the one step that you could add in is this one. You have log x to the third y to the 1/2 minus log z to the fourth. That could be the line that you could add in before you actually apply the power rule to the front. Okay? You are expanding here. The last little bit that you need to do is to separate this x to the third times y by using the multiplication rule. Multiplication rule turns into addition. And then on top of that, you got another power. So you bring that to the front. And then distribute. And then you're done. A lot of times it's easier if you do it yourself. Okay? So we'll look at the expanding example now, and then we'll go back and look at the condensing one. Okay? So we're going to expand this. How should I start? Change that that square root to the half power. So this becomes log of x, parenthesis, xy to the 1/2 power over a squared. What's the next thing I could do? Just the x1? Ooh, I'm going to do a few things before I apply that power. Quotient. Who said it? Good job. Quotient. Separate those. That's log x times xy to the 1/2 minus log a squared. So I can use power with this last one and say that this last part is 2 log a. Very good. So the back end is done. Now I need to worry about that front end. Say again? Not yet. Before I can use power with that 1/2, I have to use another rule. Abby? With what? If you're going to do them all at the same time, it's going to be kind of a lot. I'm going to break it up a little bit, okay? Just for those who might still be having some difficulty. This is x times xy to the 1/2. So split that one up first. You're trying to... Y'all trying to go like almost straight to the end, missing them steps in the middle. Does everybody see that? That x is being multiplied to that quantity, so you have to split that up. And now at this point, you can apply your power rule, which is that 1/2, and I can bring it to the front of just that middle log. And then what you say, Joanie? And then I can expand that and use multiplication rule. Now this is showing every step. Still kind of not done, but will I write all this out only if someone is struggling? One last thing I need to do. Distribute what? The 1/2. And that is your final answer. No.
Good afternoon, everyone. We have just a couple of announcements. We'll give you just a minute for everyone to be paying attention. We've got some that you will want to hear.
Okay, so for this last problem with condensing, you're basically working backwards. This time you now have numbers in the front, addition symbols and subtraction symbols, which means that in order to condense it, you basically need to apply multiplication, division, and then the power rule, bringing it back to the exponent. So the easiest way to condense is by taking care of any numbers that are in the front. So any numbers that are in the front, they need to be moved to the exponent by applying the power rule. So this becomes the ln of 3 to the 4th power plus the ln of y to the 6th minus the ln of x to the 1/2 power. So once you've applied the power rule by bringing the exponent to the front, now you want to apply either the multiplication rule or the quotient rule. All right. And so by doing this, I'm going to apply the, multiplication rule. I'm going to end up multiplying that 3 to the 4th by the y to the 6th. So this becomes the ln of 3 to the 4th, y to the 6th, and then minus ln of x to the 1/2. Okay? Now that I have subtraction, I can condense it even more by applying the quotient rule, which becomes ln of 3, a big ln, ln of 3 to the 4th, y to the 6th over x to the 1/2. Okay? Now, this right here would be acceptable as a final answer. However, if you wanted to go that one step further, 3 to the 4th is 81, so that turns into an 81, y to the 6th, and we can rewrite x to the 1/2 as the square root of x. And so then this would be the most simplified answer, more than likely a multiple choice answer if it was ever a multiple choice test. And that's how you would condense logarithms. You basically are taking the properties, instead of having additions and subtractions and numbers in the front, you're now going to have exponents, multiplication, and division. When you're expanding, you're going from multiplication, division, exponents to addition, subtraction, and numbers in the front of your logs. Okay. Now I had all these extra examples here that I thought that we would have a chance to get to just to practice all the concepts that we did today. But because we ran out of time, I definitely want to make sure that that in this video I at least get you some extra practice. So this is what you should add to your notebook pages, beside wherever this foldable is located. So here we're going to expand each logarithm. Remember, when you're expanding, you're taking your multiplications, your divisions, your exponents away, and you're going to have addition symbols, subtraction symbols, and numbers in front of your log. So because this w to the 6th power and the square root of u are connected by in multiplication, you are going to rewrite that multiplication and use addition. So this becomes log base 6 of w to the 6th plus log base 6 square root of u. Now, we can rewrite the square root of u as u to the 1/2, and I could have done that from the very beginning, but I already started, and that was my first thought process. But you could have done that there. And now the last thing I have to deal with are my exponents. And remember, we apply the power rule, which means the exponent is now going to go to the front. So we're going to have 6 log base 6 of w plus 1/2 log base 6 of u. And that is as far as you can go. There's no more multiplications, there's no more divisions, and there's no more exponents. Okay? Now, one thing I do want to point out is that 1/2 log base 6 of u could be written as log.
Crystal Crawley, if you're on campus, you are needed in the front office. Crystal Crawley, come to the front office.
is that that 1/2 log base 6 of u could be written as log base 6 of u divided by 2. This and this are the exact same thing, just written in different ways. And the reason why I wanted to point that out is for this type of problem, okay? I want to condense each expression to a single logarithm, okay? And the reason why I want to point that out is because when you see this log of 8 base 8 of u divided by 3, that's the same thing as saying log base 8 of w plus 1/3 log base 8 of u plus 1/3 log base 8 of v, okay? They're just the same thing, all right? And now to condense some single logarithm, remember condensing, you want to take all your numbers in front of your logs and move them to the exponent. All your additions, change them to multiplication. All your subtractions, change them to division. And before you can ever apply multiplication or quotient when you're condensing, you want to take care of all of your numbers in the front. So then this becomes log base 8 of u to the 1/3 plus log base 8 of v to the 1/3. And now I can apply my multiplication. So then this becomes log base 8 of w times u to the 1/3 times v to the 1/3. And that's it. No more numbers in front of your logs. No more addition. No more subtraction. This could also be written as log base 8 of w cube root of u cube root of v. And that would be acceptable. And actually, I wouldn't even have to separate them like that. I could actually, let me fix this. Just make it like this. Okay? And that is how you condense logarithms. Okay? So, work on your homework. Bring any questions you have to class for our next class.